Okay, so these are the measures of the angles in terms of radians that you should have. This is one of the key concepts. This is actually a part of pre-calculus, and this is one of the foundational things. So this is important to understand for pre-calculus, calculus, and beyond. What we want to do next is match up the degrees. So that'd be 360 degrees. Add 30, well, it would be 0, also 0 degrees. So this would be 30 degrees, 45 degrees, 60 degrees, 90 degrees, add 30, 120 degrees, 90 plus 45 is 135 degrees, 120 plus 30 is 150 degrees, 180 degrees, 180 plus 30, 210 degrees, 180 plus 45 will be 225, 110 plus 30 is 240 degrees. This will be 180 plus 90 degrees, and that's going to be 270 degrees. This is 270 degrees plus 30, so we get 300. 270 degrees plus 45 degrees, that's going to be 315 degrees. 30 degrees, 300 degrees plus 30 degrees will give us here. That's 330 degrees, and if we add another 30 degrees, we'll get back to 360. So this is really key. I would highly recommend learning this very well. It's likely something like this will show up on a test. Can you fit and match up the radians and degrees of a circle? So again, these red and blue measures are the radians, and they correspond to these degree measures. So if we said take an angle of pi radians, well, that would be the equivalent of saying 180 degrees. Okay. So we can convert from radians to degrees and degrees to radians. So that's what we're going to do now. Converting from degrees to radians. So if you were given 20 degrees and asked to convert this into radians, well, we just multiply it by a factor. We want pi to be in there somewhere, so there's going to be pi in the numerator, and we just use this over here. In pi radians, there's 180 degrees. So you can switch them from the numerator and denominator. We want to go from degrees to radians, so we're going to put pi in the numerator, degrees in the denominator, and actually you can think about it as our degrees will cancel out. And our zeros will divide out. And this 20 degrees looks like will be 2 pi over 18, and this is pi over 9. Okay, so 20 degrees equals 2 pi, sorry, just pi, over 9. What about 315 degrees? We could look on our unit circle, and we can see 315 degrees equals 7 pi over 4. But how would we do that if we didn't know? Well, we would multiply by pi over 180 degrees. Our units of degrees will cancel. We will have 315 pi divided by 180. Well, that's a big mess. Well, I can see we can divide these by 4 pretty simply. Let me grab a calculator. And 315 divided by 5 is 63. Sorry about that. Um, 63 pi over 180 divided by 5, that'll be 36, I believe. Yes, 36. And we can see these are both divisible by 9. So 7 pi over 4. And that's 315 degrees. And that's just what we get over here. So degrees to radians, multiply by pi over 180. 180 degrees. That's our pattern here. Now what if we want to go radians back into degrees? Well, this is also very similar. Let's say we have pi over 8. Well, we want to go into degrees, so we want our pi's to cancel out. So we're still going to use 180 and pi, but pi is going to go on the bottom this time, so pi's will cancel out. That means 180 will go on the top. This is degrees, this is not degrees. Pi's will cancel, so this will be 180 over 8. See, divide them both by 2, we'll get 90 over 4. Can divide them by 2 again, we'll get 45 divided by 2. And in degrees, this will be 22.5 degrees. Just simplifying fractions there. If we want to do, let's do a negative one. Negative 7 pi over 12. We want to turn this is in radians, so 7 pi over 12. Negative 7 pi over 12. I'm not sure where that would be on our unit circle. But we just do 180 over pi, multiply by 180 over pi. Our pi's will cancel out, and we're left with negative 7 times 180 divided by 12. And I wonder if this will work out nice and neat. Let's just try it. Negative 7 times 180 divided by 12. Yes, it does. We get negative 105 degrees. So negative 105, so that would start at 360, 270, it'd be somewhere down here. Be 255 degrees. And they would be coterminal with that. Okay, so the way we go from radians to degrees. Multiply by the reciprocal of this. 180 degrees over pi. There's pi radians in 180 degrees. Okay, so that takes care of coterminal angles, converting angles from radians to degrees and degrees to radians. Let's take a look at one story problem. And that will be in our next video.